Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. So today we are going to go through the second lesson of Algebra 1. Last time, if you remember, we solved equations. We called them a one-step equation because all what you have to do was just one thing to solve for your variable. Today we are going to extend that. I hate to say two steps and then, multi-step. That we say more than one step. So let's see. I have here a worksheet uh, for Algebra 1 that consists of 16 questions. I think we don't have time to do all 16. So I don't know if we can pick, for example, I don't know, 4 divisible by 4. So we take 4 problems. If we see that it didn't take long, we can extend and take maybe 2 more or something. So let's start with number 4. Number 4, let me rewrite it here so we'll be on the same page. Unintended. Number 4, it says negative 40 plus 24x plus 15 equals 52 plus 18x plus 17x. So what we need here, as we learn, is to have all the x's on one side and the constants on another side. So the problem would be easy to solve. There are many ways to do it. I think the easiest way is to combine like terms on both sides and then move things around. So step number 1, we are going to combine like terms. What do I mean by like terms? If we have terms containing the variable, I combine them together. If I have constants, I also combine them together. And then later, when we start looking at higher level equations, we are going to use the same concept, exactly the same. So if I look at the left-hand side, I see a negative 40, that's a constant. 24x, that's a variable. 15 is a constant. So I have 2 constants. So let's combine them. The 24, first of all, the 24x remain the same because there is nothing else to combine with. But negative 40 plus 15 is negative 25. You can use your calculator if you wish, but you will get negative 25. On the right-hand side, however, I see 1 constant and 2 variables. So the constants stay the same, but the variables, I'm going to add them up. So 18 plus 17 is 35. So 18x plus 17x is 35x. Be careful, by the way, I've seen it, especially with beginners or novice, when you are taking algebra for the first time or you are new. Excuse me. People add the 18x plus 17x and they say, oh, 18 and 17 is 35, and they write 35 without the x. That's unacceptable. Because remember, x in a word problem may be, for example, a number of tickets or, the cost of something you buy. So it's not a number. It's how many of x's do you have? How many x's do you have? And you tell me, what is x? Again, it depends on the problem. Sometimes I'm going to make x the length of, say, a square. Maybe I make x the cost of something. Maybe x is the number of people, and so on. And x is the height of a building. So whatever is unknown, is variable, we call it, is x. So be careful, please, when you do these things. Dropping the x will get you a completely wrong answer, and so on and so forth. Now that becomes a little tricky because I combine everything. So what do I do after that? Remember, our job is to make all the x's on one side, to have all the x's on one side and all the variables in another. So I can either move the 35x to the left or the 24x to the right. And because many people, as I said, prefer to have the variable on the left and the constant, because that's how we are programmed or how we learned, right? So we do the same thing. So for example, I have a 35x there and I don't want it. So it's added to something. So subtract it from that thing, because the plus and the minus are inverse operators. They cancel the work of each other. But if I did it to the left-hand side, I have to do it to the right-hand side. These cancel. And then I use my calculator, 24x. Of course, you cannot enter x. And that's probably what caused the problem, is that on your calculator, you get negative 11, because you're going to say 24 minus 35. Notice you cannot write 24x minus 35x. So you say that and you get negative 11. So people write negative 11 minus 25. Now, remember, you kept the x. You have to write it back. These are minor things, and usually nobody thinks about them, but I've seen it a lot. So I'm not really comfortable with leaving things without explanation. The next thing, so I'm going to say negative 12x minus 25, negative 11x minus 25 equals 52. Now I got the x's, all the x's on the left, but I still have a constant. Again, it's subtracted from something, so I add it to that thing, and I add it on the right. These cancel each other, and then I get negative 11x equals 77. And finally, because I want x by itself and x is multiplied by something, I divide by the same thing. Again, opposite of multiplication is division. So if it's multiplied by x, remember there is nothing between them. So it's a multiplication. And then I divide by the same number. And I get x equals negative 7. Yeah, many steps, but nothing is hard. I'm just adding and subtracting and multiplying and dividing. This is what I learned in elementary school, so nothing hard. Let's move to number 8. Number 8 says negative 18 minus 39r equals 78 minus 36r minus 6r. So when I look at the left-hand side, I see a constant and a variable, nothing to combine. There is no like terms. On the right-hand side, I have a constant, a variable, two variables. So I'm going to combine them into one. Negative 36 minus 6 is negative 42. Or if you do it with a calculator, you will get negative 42. Don't forget the r. Okay. Now, because I want only the variable on the left-hand side, and I have negative 39r and negative 18. So maybe I can add 18 to both sides. So I get negative 39r equals, this is 96 minus 42r. I still have r on the right-hand side. I don't want that. So I'm going to add 42r. And since I add it to the left, I add to the right. Notice we don't write plus at the beginning of an expression. It doesn't make any difference. Now, 42r minus 39r is 3r. And the left and the right-hand side now is only a number. So the 3 is multiplied by the r, so I divide by 3 to release the r, so to speak. And then since I divided on the left-hand side, I divide on the right-hand side, and 96 over 3 is 32, so r equals 32. Okay, I hope I'm not going fast. They are similar, so that's why I should have picked a different different question, but anyway. Let's see. Number 12. Number 12 says, that's a new thing we haven't talked about, so we are going to illustrate it here. Plus 6, parentheses, 8 plus 6x equals 52 minus 10x. Oh my God, now it's complicated. What is this? There is a 6 followed by a symbol, which is like a parentheses. So what's between them? If I don't write an operator, it means it's multiplied. So why do I have parentheses? Because the 6 is multiplied by the 8, and the 6 is multiplied by the positive 6x. So instead of writing 6 times 8 plus 6 times x, I say, okay, since both of them, each one of them is multiplied by 6, let me take the 6 out. In fact, I could have taken 12 out, but that's a different story. So how do I return them back? Have you heard of the distributive law? We are going to distribute the 6. So you say 6 times 8 plus 6 times 6x. So the first thing I have to do is to break down this attachment and make it look like this, the previous problem. I have a 4, and I have a positive sign, and then 6 times 8 is 48, so I say 48. I have positive times positive is positive, and 6 times 6x is 36x. Wow, it looks something similar to this side, right? But here I had 2 variables and a constant. Here I have 2 constants and a variable. In fact, like this one, it has 2 constant and a variable. The right-hand side is just 1 constant and 1 variable. So now it became like the previous problem. Okay, so it's very important to know if there is a number outside the parentheses, it means that number is multiplied not only by the first, no, by everything. If I have 8 plus 6x minus 4 plus 8x minus 17, I have to multiply this. I can combine what's inside the parentheses and then multiply the 6 by them, or I can multiply the 6 by each one of them and then combine. It's the same thing. Okay? Usually we combine what's inside the parentheses as we follow the PEMDAS, as we will talk about that later. Even though I have a couple of comments on this, I don't want you to be like a robot, programmed to do steps in sequence, because now you are not thinking. You know, oh, they told me to do this, but can I do it slightly different and make the problem easier? Yeah. So why memorize? Okay, we'll talk about that later. Now we are going to combine like terms. I don't have like terms on the right-hand side. I have a constant and a variable, but on the left, I have 4 and 48. So I add them up and I get 52 plus 36x equals negative 10x. And I have 52. Why didn't I write? So I want all the x's on the left. So I'm going to add, notice the 10x here was subtracted. So I have to add 10x to cancel that. It's the inverse. So here I get 52 plus 46x equals 52. Wait a second, I have 52 and 52. So I want to move this to the other side. It's positive, right? So I have to subtract. That's interesting. I got 46x equals 0. What does that mean? It means that x has to be 0, because you cannot multiply a number by another number and get 0, except if one of them is 0, right? And since the 46 is not 0, then the x is. You divide both sides by 46 to release the x, and you get x equals 0 divided by anything is 0, so x is 0. Meaning if I hide the negative 10x and I hide the 6x, do you see what I get? 4 plus 6 times 8 equals 52. Yes, it's correct. 4 plus 48 is 52. So the x doesn't have any effect here. X has to be 0. If it's anything else, you cannot get the left-hand side equals the right-hand side. Okay, number 16. Number 16 says 11 times 14 minus 12v minus 7 equals, I'm sorry, equal, I did 16, yeah, equals negative 3v plus 18. This is identical to the previous one. The 11 here has to be distributed. It's positive 11, so I say positive 11 times positive 14 is 154. And then positive 11 times negative 12 is negative 132v. Don't forget the v. Minus 7 equals negative 3v plus 18. I have two constants here, so I add them up. 154 minus 7 is 147. Minus 132v equals negative 3v plus 18. Since the v on the left-hand side is negative, I prefer to move it to the right and make it positive, but let's say we are not going to do that. We are going to stick to what we are doing so we don't get confused. I want all the v's, all the variables on the left and all the constants on the right. I have a 147, positive 147 on the left. I don't want it here. So I subtract 147 from both sides. So I get negative 132v equals negative 3v, and then I have a negative minus 129. Later on, when you get a problem like that and all the signs are negative, you can just make them positive. How? Doesn't that change the problem? No, it's not going to change the problem because I'm going to multiply both sides by negative 1. Why? Because it's easier for me to use positive values. You don't have to do that. So if I say I'm going to multiply the left-hand side by negative 1, it will become 132v. I'm going to multiply the negative 3v by negative 1. I get positive 3v. And I'm going to multiply the negative 129 by negative 1. I get positive 129. Let's solve it both ways and see what we get. On the left-hand side, I have a v, but on the right-hand side, I have a variable and a constant. The variable is subtracted, so I'm going to add it to both sides. So now I have to combine like terms. 3v minus 132v is negative 129v. The right-hand side is negative 129. If I did it here, I'm going to subtract 3v from both sides. And then I have to add the positive because I didn't have it here. These cancel, and I get 132 minus 3 is 129. So I will get 129v equals 129. It's the exact negative of that. This is multiplied by negative 129. So to release it, I divide by negative 129 both sides. These cancel. So I get V equals 1, right? And here I would have divided by 129, and I still get V equals 1. Don't worry about that for the time being. Let's keep it for later. But you see, you can do many things. In fact, I could have solved it completely different. But at the end, if I did all the steps correctly, I should get V equals 1. I think that would be enough for these types of problems. Next time, maybe we'll start introducing the PEMDAS and see, the steps we are taking. In fact, I could have introduced it here, but I didn't want to make the session too complicated and cover multiple things. Take it step by step. Hopefully each lesson would be easy. By the time we finish, we are going to build a very strong foundation and we'll be very confident going into Algebra 2 next semester. Thanks for your watching and hope to see you soon.